Stay away. Okay. Hello, everyone, and welcome to our talk. This is my co-presenter, Max. My name is Philip. Martin, unfortunately, couldn't be here, so I substituted for him for this talk. We're both engineers at Neo4j, working on bringing more powerful graph capabilities to Spark. And given that we're all at the Spark conference, for you the question is probably, why graphs, right? So graphs are everywhere, and I'm going to give you 3 interesting use cases where looking at your data as a graph really made a difference. The first one is about the web. Some of you might remember when web searches started in the 90s, web search wasn't very good. The web was essentially looked at as a set of documents, and when you entered a query, it just looked at which document from that document catalog had the best keyword match, and that wasn't a very good search result. So one of the key innovations from Google was to look at the web as more as just a set of documents, but to actually look at the connections, at the hyperlinks between the documents. And they had their famous PageRank algorithm that looked at the website and would categorize it higher if it had links from other important websites linking to you. And so that's a very good use case of how looking at the connections between your data can result in a better feature. The next use case is something I'm really excited about, space travel. So some of you might know that NASA is working on Project Orion. So they're scheduled to send humans to Mars in 2033. And NASA has a lot of data going back decades. Many engineering lessons learned, things they know. And there's knowledge architect David Mesas that thought that this is great that they have this data, but it's very hard to find anything an engineer was looking for. So what he did was he did topic modeling based on these engineering lessons learned, and made it much easier for engineers to find out what previous lessons had been learned that could apply to the current problem at hand. And he said that engineers working on Project Orion benefited from engineering lessons learned decades ago during the Apollo era based on that. So essentially, linking up these different lessons learned made them much more useful because it wasn't anymore just a keyword search, but you could actually see how the lessons related to each other and what other lessons might be applicable to your problem. The third use case where graphs are interesting is pretty famous. It's the Panama Papers. So the Panama Papers was one of the biggest data leaks ever. So the International Consortium for Investigative Journalism got more than 10 million documents about essentially how rich people were hiding their money with shell corporations and complex company structures. And they factored the work out to make sense of that to journalists all around the world. And you might have been reading about some of their findings, but if you think about it, it's not easy to make sense of 10 million documents. How do you even go about finding anything, especially if the structures themselves were designed to obfuscate the connections between things? So what they did was they extracted information from those documents and turned them into a graph, where they could use a graph database to find the connections between these hundreds of thousands of entities, and the journalists could actually do their investigative work. Now, graphs aren't just everywhere. So what you see here is a diagram from dbengines.com tracking the relative increases in popularity for different database paradigms. And you see the green bar at the top, that's graph databases. So they've been growing a lot in popularity in the past 5 years. And that's not just some random statistics. If you look out to the big cloud providers, for example, Microsoft Azure, they have Cosmos DB now that supports a graph model, of a graph way of looking at your data. Or Amazon just released Neptune that allows you to store graphs and query for graphs. So graphs are really an interesting thing and coming. Now, I'm going to give you an introduction to the property graph model. It's probably one of the most used ways of modeling a graph. It's used by both Cypher by Neo4j and Gremlin. They look at a graph that way. And the property graph model has a basic thing that's called a node. A node could be something like a person or a car. It's a basic entity in the world that you want to describe and make connections with. So in the diagram, you see 2 persons and a car. So that's 3 nodes total. And the thing, we already want to label this. So yeah, we label 2 things as person and the third thing as a car. That's a way to categorize what kind of a thing that entity is. And you can have multiple labels too for a node. And now comes the crucial thing for a graph. relationships. So these nodes, you can connect them with other nodes, and these relationships always have a start node and an end node, so they're directed, and they have exactly one type. So in that diagram, you see a person drives a car, two persons love each other, another person owns a car, and this is the crucial thing about graphs. They connect entities, and these connections are first-class citizens, so you don't need to reconstruct these connections indirectly, but they're a first-class thing in the model. The third thing are just properties. They're essentially ways to describe nodes and relationships. So for a person node, we might want to know what is their name, what is their birth date, what is their Twitter handle, or for a car, we might have properties such as the brand and model. Properties are just additional information about entities. They always have a name, which is a string, and a typed value, which can have many different types. Now, modeling your data in a certain way doesn't help you. You don't have a way to ask questions about your data. And when you model your data as tables, you would use SQL for that. Now, I'm going to introduce you to Cypher, which is essentially SQL, but for graphs. Just like SQL, it's declarative, so you don't say do this and then do that. So essentially say what you want to have done, and the query engine will have to figure out how to best execute and maybe optimize that. Now, what's missing from SQL for a good graph query language? It's the patterns, right? How do you ask questions about graph patterns? And the way you do that in Cypher is you build ASCII arts. You try to sort of mimic the way you would draw that pattern on a piece of paper with ASCII characters. So in this example, you have a person, Dan, that loves another person, Anne. And in Cypher, you would essentially model that by having the parentheses sort of model the node. And then you have this arrow character with loves in the middle that goes to the right-hand side, which is another node. And the relationship, the arrow is labeled with loves to say, hey, this is actually a loves relationship. And for the nodes, you can specify the label at the front, and then you have curly braces, and there you put all the properties. Now, that's not a Cypher query yet, so to turn this into a question, it also wouldn't be a question because it declares all the information already. So to turn this into a graph pattern, a good question for a graph, you'd replace the pattern for Anne, for example, with a variable whom. So now whom is what you're looking for. So the first thing is something fixed in the graph, and the second thing is what you're looking for. And when you say match, you're essentially asking Cypher to match all these whoms that fit in the graph, that match this pattern in the graph. And you say return whom to say, please return all the bindings for whom to me. Now, putting it all together, if you look at this and you're familiar with SQL, that should look very familiar. So you have a from clause, where in Cypher you say where you want to match patterns. And in this case, we're matching patterns from a social network. And then you see that pattern that I just described, this match clause, right? Where you say, we want a node that has property Dan, a property name with value Dan. And then it's connected to a variable called friend of a friend. So that's the variable that we're binding to. And for that relationship, you see something interesting is a *2. That means that's 2 hops out. And there you really see the power of Cypher. It makes it really easy to ask questions about relationships between things. This means don't give me 1 hop friend, but give me the friends of Dan. And it's very easy to express. And you could also easily express something like 2 to 4, which would be a real pain to write in SQL. The return clause in the query says what you want to return as the columns in the table. So this query returns a table result. So this table is going to have 1 column called name. And we apply a function to that. So that's pretty standard if you're coming from SQL. You can also order things. You should be able to make sense of that if you're familiar with SQL. Now, this version of Cypher that we implemented is not exactly the same as the standard, the openCypher standard, because in a Spark world, things are immutable. And openCypher currently is mainly designed for databases like Neo4j that assumed that the graph is mutable. So essentially, we needed to extend Cypher with constructs that allow you to deal with immutable graphs. So the thinking went more from having 1 graph and modifying it to having many graphs and transforming them. And the way we extended that language is to add a construct clause that allows you to create a new graph. So in this case, it's something like the people you may know feature on Facebook, essentially saying, give me all the friends of a friend from a person, and then, but not people that this person is already friends with. So that gives you people that the person might have met before, so possible friends. And that's what we do here with the create. We create a new relationship that directly connects the person with those friends of friends called possible friends. And then we return a graph. So that's a big difference between this construct query and the one I showed you previously that returned a table. This one returns a graph, not just a table. Now, what you can also do in a world with multiple graphs is you can have multiple from clauses. So in this query, we're trying to do something like data integration between different data sets you might have. So in companies, very often you have different data that sits in different places, and you want to bring it all together. And graphs are also really convenient for that. So in this case, we have one graph that's a social network, and another one that's a product graph. And we're first matching all the persons from the social network graph, and then we're matching all the customers from the product graph. Now, some of these nodes in these graphs are going to refer to the same real-world thing. And the way we try to figure out which same people might be behind those nodes is via their email address. So essentially, the assumption is that if two nodes have the same email address, they refer to the same person. And then we use another new construct. So in this case, we don't just construct a new graph, but we construct on top of other graphs. So the final graph we're constructing here is both the social network, the products, and then this newly created node here. Person is C. So essentially we say that person is that customer. And this is how we bring all these graphs, how we take both graphs and connect them. So this is like a data integration scenario. And with this short introduction to both the property graph data model and Cypher, I'd like to pass on to Max to tell you how we brought all of that to the Spark platform.
All right. So let us begin by having a look at the data modeling landscape with respect to the relational model and the graph model as it is today. So if we have a look, for your traditional transactional use case, in the relational data model where we represent data as tables, you would probably use a relational RDBMS like Postgres or MySQL. As Philip already said, we are from Neo4j and we like to work with graphs. So in that very case, we would opt for an option like Neo4j graph database that's optimized for OLTP transactional workloads. However, if we have a look at more analytical workflows and data integration processes, especially with respect to large data volumes, then the relational community has been in the good situation that they could revert to tools like Spark SQL, which allows us to process data in large data volumes in a distributed fashion. However, for the graph space, we think that this field has been not completely filled. So this space basically has been lacking a solution where you could leverage the power of graph database query languages. And we wanted to fill this missing piece by introducing Cypher for Apache Spark. The way we like to think about Cypher for Apache Spark is that it is the Spark SQL for graphs. And let me make this analogy more clear by comparing Spark SQL and Cypher for Apache Spark. So in Spark SQL, our main data model are tables, which are represented as data frames by Spark SQL. Of course, if you want to query those tables, we can either use SQL, or we can write our custom process code using the data frame API, and by writing programs that take an input, which is a immutable data frame, and then output immutable data frames. On the other hand, for Cypher for Apache Spark, instead of tables, we use graphs. And those graphs we query with the Cypher query language that Philip just introduced. Now, the good thing about those two systems is that they both set up on the data frame API, which makes them not only interoperable on a Spark cluster, but they can also work together. So you can pull both libraries into your project and then make them work in conjunction. So you can find the best way to solve your task using the strengths of both systems. Yeah, Cypher for Apache Spark was developed by Neo4j. We've released it under the Apache 2 license, so it's open source code that you can find on GitHub. If you just Google for Cypher for Apache Spark, you will probably find it. We've also released a binary on Maven Central, so you can just pull it into your project and get started. It's still in a more or less early phase, but it's still it's already very usable, so we would really like if you go and check it out. Our API currently only supports the Scala programming language, but in the future, we plan to add support for Python, Java, and maybe even R. And since, as a graph company, we would like to bring graphs as first-class citizens into the Spark ecosystem, we are considering to open a Spark improvement proposal to bring certain functionalities of Cypher for Apache Spark into the Spark framework. And that is why we are in ongoing discussions with Databricks and the GraphFrame developers. And the idea is here to bring a data frame-based graph solution that supports Cypher directly into the Spark framework, so that no additional library would be needed. Let me give you a high-level architecture overview over how the system actually works. So as I already said, on the very bottom, the very basis, is the Spark SQL data frame API. On top of that, we've built Cypher for Apache Spark and its more commercial sister product, which we call Neo4j Morpheus. Cypher for Apache Spark itself consists of two main parts, the query engine, which takes care of translating a Cypher query into a Spark SQL or data frame API calls. And then we have the property graph catalog, which allows you to read data or to store and read data from different property graph data sources that can be, for instance, Neo4j or file-based formats like CSV, Parquet, or org, or even SQL databases that either support Hive or JDBC. Additionally, we also support views. They are more or less parameterized query functions. So they are a bit more powerful than the standard SQL view you'd know, because you can additionally pass parameters into your view definition. And then, as I already said, we are going to offer a commercial product around this, which we call Neo4j Morpheus, which has commercially support for Cypher for Apache Spark, as well as certified integrations with certain cloud providers. If you want to know more about Neo4j Morpheus, then I can happily forward you to the talk of my colleagues, which will take place tomorrow at 11 a.m. in Capital Room 12. All right, so now, if a user enters a Cypher query into our system, how do we actually process this query? So we start with the query string, which is actually only a string, and we pass it into the openCypher frontend, which is a piece of code that we actually share with the Neo4j database. It's responsible for turning the string into a machine-readable format we call the AST. The AST is then normalized and rewritten, so there are some optimizations actually happening, and then we also do a semantic analysis to make sure that the query is actually semantically correct. We now then pass this optimized tree into the Cypher for Apache Spark framework, which takes care of importing all the data from the specified data sources. It validates the schema, checks the schema, and handles the type, because differently to Neo4j, Cypher for Apache Spark is actually a type system, a schema fixed system. And then, of course, most importantly, CAPS handles the translation of the Cypher query operators into relational operators. We then pass those operators through Spark SQL. It's a normal pipeline. They are, the plan is optimized by the Catalyst framework. Currently, we only support rule-based optimization, but we plan to add support for the cost-based planner in the future. And then the optimized plan is executed using the Spark core framework on the distributed cluster. I think it's time now to give you a short demonstration about how our API actually works, and also show you a short use case of how we imagine Spark, Cypher for Apache Spark can be used in the wild. The thing that we actually want to present is a simple recommender system. So we have two data sources. We have a Neo4j data source. We have a Neo4j database that stores a social network graph. And on the other hand, we have sales data that lives somewhere in a HDFS, for example, in CSV file format in our case. And we want to integrate this data to give recommendations to the user to what products they might want to buy. We've integrated this into Zeppelin. So you can simply load Spark and Cypher for Apache Spark into Zeppelin and then work with it. But let me first show you how the Neo4j data looks. So it's basically, it's a graph where we have, I think, what's the person? The red dots are persons. Those persons, they know one another. We have informations about the person's interests. So this person is interested in books. It's very synthetic data. And we also know some information about where those people live. Now, what we want to start with is that we want to initialize the CAP session. So the CAP session is our equivalent to the Spark session. So it actually wraps a Spark session and augments it with certain informations like the available graph data sources and views. I've already initialized this here because Zeppelin always takes quite a while to start. And now we can register a new graph data source that actually accesses the Neo4j data source and imports the necessary data into Spark. We can then register this data source again into our graph catalog under the name Neo4j. And once this is done, we can we can use this graph inside of our Cypher query. So here we just run a simple Cypher query to find find the first 20 people that are in our database. I hope this is going to work now. And then we'll do some fancy visualization of it. It's just a standard tabular output that you'd expect. So this is a query that actually returns a table. Now we can also integrate with our second data source, which is a file-based data source. So this time we don't read from Neo4j, but we instantiate a file system-based data source, which uses the CSV format, which you can see that here. And we also register this data source under the name product. And we can then, again, query the data. For instance, we want to find all the products in this database or in the CSV files. So what you can see here, we started out with a set of CSV files, but we can now interpret those CSV files as a graph. So we started out with a tabular format, which is inherently tabular, but now have a graph. And we can see some products that are for sale in our company. Now, as a next step, we can do what Philip already hinted to earlier. So we can now take both the data sets and integrate them into a new graph. So we have the persons from our social network, and we have the customers in our product and sales data. And we can integrate them using their email address. Philip already almost showed a similar query in the beginning. So we create a new graph that both includes the Neo4j graph and the product data into a new graph that is connected by the connected users and customers. And if we run this, this takes a little longer. We'll see that we now get a graph. We afterwards, just for the purpose of this demonstration, we queried that graph to find all the newly created edges. And now we see we can also this is a query that it also returns a tabular format, but we can also visualize this as a graph. So we now see that we have those persons from the social network, and we have the customers from our customer database, and we've connected them via an is relationship. And they should share the same email address in that case. So it's both Robert and then a long number. Given this integrated graph, we can now run our actual recommendation. So we start by finding a certain person in our graph, and then we find all of this person's friends and the interests of this friend. Then we take this initial person, go to our customer data set, find its equivalence in the customer data set, and see what things did this person buy, and we correlate the category of this product that the first person bought with the interests of the friend. So we can in the end say, hey, your friend has bought something that might interest you as well. And with all the things, we do some additional filtering, so we only want to recommend products that have a high rating, and we also do some things on the helpfulness and the votes that the review generated. So we can now build an integrated data set that contains product recommendations in a graph. I've already run this because executing this would take too long. So what we end up is we end up with a graph where some people suddenly have recommendations attached to them. You can see here, maybe let's look here. So this is a person, and he is recommended to buy a certain product, which is some book or film in this case. As a last step, we can now take this newly created graph and merge it back into our, for example, into our social network or into a new file on HDFS. In this case, we want to merge it back into Neo4j. We have to give some additional information on how to identify nodes, both in our newly created graph and in our base graph in Neo4j. This is quite similar to what you would do with primary keys in a relational database. And then Cypher for Apache Spark allows us to merge the data back into our system. I've already executed this as well. And now if we look at the Neo4j database, we suddenly have those additional informations persisted in our database. This concludes the demo, basically. And what we want you to at least take away from this talk, or what we'd like for you to take away from this talk, is 3 things, basically. So first, we think that graphs can help you model and find connections in your data. So we think that graphs are a great tool to use the power of connected data. Secondly, Cypher is to graphs what SQL is to tables. So we want Cypher to be one of the standard languages used in graph processing. And the most important point, Cypher for Apache Spark is the Spark SQL for graphs. If you want to use Cypher for Apache Spark, we've also already produced a documentation which is quite extensive on both the open source as well as the commercial part. You can find it under the link up here. And that concludes our talk. We thank you for your attention. And yeah, as I said, if you want to hear more about Cypher for Apache Spark and Neo4j Morpheus, we'll have a talk tomorrow at 11 a.m. Thank you.
Thank you, Max and Philip. Do you have any questions for Neo? We got 2 minutes.
Hi, I was just wondering when or if, do you think it'll move beyond kind of translating Cypher into SQL and kind of using SQL in the Apache Spark engine, or do you think Cypher will be like a lower level implementation? Is that something you expect to happen, or is that just like not going to happen?
I think,
I think we just both shook our heads. We don't foresee that happening at the moment, no. I think we have greatly benefited from being able to build on an existing distributed platform, and building a platform like that is not easy. So for the time being, for these use cases, I don't foresee that happening. But
no. And do you see that as being like, is there a large downside from performance based on that? Like, you obviously don't run Cypher as a wrapper around SQL natively.
Yeah, I mean, for transactional workloads, you're really better off using Neo4j. Yeah.
Oh, yeah.
Yeah. But I assume that's the same for using Spark SQL versus in Postgres, for example.
Thanks for the talk. It's really exciting. The question is, how does Cypher relate to Spark's GraphX library? Is that going to be supported in some shape or form, or completely abandoned, or what's the plans are for that? Because this feels like, okay, Cypher query, Cypher interpreter, SQL, which is to be a bit surprising to me, and then it passes down to the RDD layer. So what about GraphX?
Well, so we don't directly integrate with GraphX. We've done some prototyping where it's possible to take the data that's produced by CAPS and then put it into GraphX. That's certainly possible, but we don't offer any particular integration. However, there might in the future be some integration with data frames, for instance. That could be, we could think that this would be possible.
I mean, there is an equivalent version of graph frames that the open source project that Databricks is working on, but the GraphX right now, I think there's no new development going on in GraphX. So if you do anything, it's probably going to be based on data frame-based APIs, which is graph frames. We don't have enough time for questions, so please, a big warm hand to Max and Philip, and thank you for coming.